right, cool. Well, thank you guys for coming out to this talk. I'm just curious, does anyone here work with fabric, work in the textiles or apparel space? Just raise your hand. Yeah, we have a few. Okay, cool. I'm curious to learn about others' interest as well, but hopefully we can chat about that more after. So as you know, my name is Maddie. I work in the smart textile space. When I say smart textiles anytime during this talk, I'm mostly talking about electronic textiles, but generally anything that's smart or technologically advanced can also be materials advanced, it can be design advanced, so we'll go over some of those things as well. I live in Brooklyn, work in Brooklyn at a company I started called The Craden, and we do a lot of experimental research and development work in the smart apparel space. And we look at all sorts of different things. So ideas like, things like heated jackets, potentially, things like UV responsive garments, pendants that light up, garments that change shape, using computer programs to make apparel. It's kind of this weird intersection of technology, fabric, apparel, design, materials, and really exploring what's possible at that intersection. We also do a lot of client work, so we will build prototypes for companies like Google and North Face who want to try new concepts. And often at the heart of building a prototype is materials. And making a textile circuit is kind of a challenge. There's not a ton of enabling technology out there for making really robust, reliable prototypes. So something that we've been working on more recently is creating some of those core technologies. And the gift that you're seeing here is a circuit that's printed on fabric. So those lines replace wires, and you can interact with the wires. So when you press them, you can see the LED in the center changes color in response to your interaction with the fabric. Well, and so there's this question of why textiles, and I think that's a great question. What's wrong with dumb textiles? What's wrong with what we have already? And there's nothing wrong at all. But I think that fabric in general is such a strong enabling technology. It's a ubiquitous material that feeds trillion-dollar industries. And so having a variety of options and having smart textiles creates new ways for us to interact with the environments around us. A good example of why having electronics in textiles is something that's useful is for near body monitoring and being able to make electrodes that actually touch the body but don't need to be glued to the body. Oftentimes electrodes, especially with different glues that are used for heart monitoring, can have really bad allergic reactions with the skin. So being able to print them on a fabric gives you new optionality. And with that in mind, smart textiles aren't just for the fashion industry. They're for industry wear, they're for cars, they're for interiors, and thinking about them as this ubiquitous substrate for all sorts of different advancements makes it a little more interesting to think about the future of what that can mean. One of my favorite examples of seeing fabric as an enabling technology is looking at W.L. Gore, which is the company behind Gore-Tex, and DuPont, which is the company behind Stainmaster. So when people go and buy a new carpet, they'll often ask for a Stainmaster carpet, but Stainmaster is not a carpet design brand. It's an enabling technology that's used for carpet designers that is hydrophobic and stain resistant and makes your product that much better. Same with Gore-Tex. It's a hydrophobic, breathable material that we trust when we see that brand and you buy a jacket from North Face. So having these resources enables companies that are designing things with fabric to make their things that much better. Looking further into what one could say is hardware of the space is YKK. So if you look at just about any zipper on anything you're wearing, you'll see that album. And YKK makes these core technologies that allow designers to have clear answers to how to close a garment. And with that, you can get a lot more creative about designing the parts that a company might be best at. Same with 3M, which is one of the best materials companies, I think, out there. They're one of my favorite companies. They do a lot of interesting adhesives and reflective materials. And reflective materials enable companies like Nike, for example, to make high visibility garments for runners at night without being concerned about developing that custom fabric. And of course, when we're thinking about smart textiles, something that comes to mind is the wearable technology space. And a lot of people, when thinking of wearable technology, or a lot of the conversations that exist, are around smartwatches. But I think that the space is a lot more than that, especially when we look at technology as an advanced process that isn't just electronic, but can also be materials and design oriented. We start to see that wearable technology doesn't need to light up necessarily or tell you the text messages that you're getting, but it could be a materials advance that makes it a lot easier for us to live our lives in a simple way, or that makes it easier for civil workers to stay safe, for astronauts to travel. There are a lot of options when we have advanced materials that protect us in other kinds of environments. So there's this question of why be pedantic about what is a smartwatch and what is a smart garment and what is smart fabric and all of these different terms that I think the industry is still largely defining. And the purpose of that is that thinking about a smartwatch happens on a fundamentally different scale than thinking about smart fabric. So if you're making a printed circuit board for a smart watch, you're thinking about micrometers or millimeters. You're using maybe digital calipers or a microscope to investigate what's going on. If you're making a smart fabric, or sometimes we'll say textile circuit board for a smart garment, then sometimes the wires that you have are feet long. Sometimes you need to get a message from your right hand across the back to your other hand. And with that in mind, you need to use a fundamentally different tool. And a trace that's micrometers thick isn't going to cut it. You need other tools and other materials in order to make the space grow and make functional products. The great advantage also of thinking about textile circuits or smart fabrics as potentially large surface area porous circuitry is that we can start to see how it applies to other industries. If you look inside of a car seat, for example, there's a lot of logic in there that lets you move the car seat, heat the car seat. There's also a pressure sensor that tells you if somebody's in the car seat, so your seatbelt, or so that you know to put on a seatbelt. And all of this logic is circuitry. In addition, when you're wiring up your home theater system, you're generally running wires all throughout that room in order to get your projector and your different cables set up. And if you can think of something that's flexible and thin, like wallpaper, similar to something flexible and thin like fabric, there are new opportunities and ways to run wiring over large surface area than just pinning it to a wall, hiding it away, and hoping that nobody sees it. And so with thinking about wiring and circuitry and smart fabric, there seems to be a shift about how we want to wire things up, where you don't necessarily want to plug in a bunch of wires different places. Maybe you want to use materials that make more sense for the space. Things like conductive fabric and conductive inks. A lot of people as well are looking into conductive threads, and finding materials that are more native to fabric is an interesting solution to actually put some of these smart fabric products into supply chain. Of course, there's always the question of, okay, let's say that we can make these things, but what do people want them for? And so we did a survey around what people would want from their clothing if it could do something additional, if they could have another function, or if they wore a personal uniform. And we got a lot of somewhat comical, somewhat serious, just a large array of answers. But one of my favorites was the answer that I want my smart clothing to be magical. And at the end of the day, I think that people are looking for interactions that are unexpected, simple, and super functional. And just to think that I can put in a location and my phone will tell me where I'm going is kind of a magical thing. It's somewhat of a relief that I don't have to figure this out. And so having clothing that can sense that you're cold and then heat you up is kind of a magical interaction that's simple and really functional and potentially useful. I think the technology hype cycle is also an interesting thing to look at for this industry, because we hear a lot of promise about wearable technology, smart fabrics, what it will do for us, but we don't see a lot of these products get to market. And I think that 3D printing experienced a similar hype cycle, because in press we saw that you'd be able to 3D print your home, but if you've ever used a MakerBot, there's no house coming out of that. You put in plastic, you get out plastic, and they're amazing machines, but they have limitations, and they're good for really specific geometries and specific things. And what will push the 3D industry forward is being able to use new materials, having new enabling technologies, having different kinds of machinery and different printer bed sizes. So looking at smart fabric and smart garments, having different kinds of enabling technologies for making smart apparel is really the way to start seeing useful things. And even more so, having supply chain for producing better enabling technologies in this space is how we can all have those more useful things. Yeah. Oh, with that in mind, a lot of what's happening in the wearable tech, textile circuitry, textile space is all about recombinant innovation, where people who are not necessarily electrical engineers or hackers by trade are using tools that are off the shelf to make the things that they envision become reality. And it's an exciting time to be working on projects because there's a lot of very abstracted technology. So you don't need to know how to program at the basic level. You can use Arduino and abstract things up and get a really simple program running in a hardware environment. And creating tools for recombinant innovation is a great way to let creative people play with different kinds of fabrics, different kinds of electronics, and come up with new products that people might really enjoy having. And with looking at that process of bringing things together in different ways for recombinant innovation, I love referring to the quote of Bruce Mau's studio, which is that a studio is a place of study. The goal is to come out with more information than you come in. It's not about making something hyper-specific. And contrasting this with books around, or the concept of techno-solutionism, to save everyone, click here, is a criticism on techno-solutionism. I think that sometimes it's just really important to look at the tools available for a process just as much as it is to look at the outcome, which is part of why this talk is focused on smart textiles, not necessarily smart clothing, because if we look at the tools available and look at the processes available, it says a lot about what an outcome could be, but looking at the tools is a really important place of study to come to important and useful conclusions. So with study in mind, I thought I would share with you guys a new project that we worked on recently with the idea of studying this process of making smart garments, finding good purposes behind them, and learning about rapid prototyping in the space. And we paired up with a company called Strong Arm Technologies. They're also based in Brooklyn, and they make exoskeletons for industrial workers. And the skeletons help people lift, they help maintain posture. In general, the goal is to keep workers safe. But because they're these rigid objects, you miss out on the opportunity to get some vital biometrics. You miss out on the opportunity for certain haptic feedback and things that are harder to achieve when you have a hard shell, rather than something that's soft and flexible and very close to the body. So we worked with them to figure out something that could augment their exoskeleton, and came up with a few biometric monitoring inputs that could keep workers safe. One was specifically posture. So you're in a different position if you're lifting something with your legs versus your back. And if you lift something the wrong way, the circuit that we designed will give you haptic feedback. It gives you a buzz on the shoulder to remind you to lift properly. And then their exoskeleton gives you support in lifting properly, so they work hand in hand. We also put electrodes on the garment for a galvanic skin response. So if your skin conductivity is too high, you're probably sweating a lot, you're probably a little overexerted, and then you can get another buzz to tell you to potentially stop working and take a break. And we also use a temperature sensor from a company called Bombutan. They're also in Brooklyn. And it's a thin film temperature sensor, just so that if the temperature inside of the vest gets too warm, then the worker's probably overexerted and needs to take a break, relook at what they're doing and make sure that the environment is safe to work with. So with those 3 inputs in mind, we took this full stack design approach and designed the harness from the bottom to the top in our studio, including the circuit, printing the circuit, the design of the garment, all of the above. So what you'll see on this slide is designing the layout for the garment, also designing the circuit, printing that circuit on a custom CNC machine that we built, and then using custom conductive inks that we've developed that bond well with cellulose and muslin fibers to print on the conductive traces. We then attached all the components, programmed the circuit, fit the garment onto a mannequin, and then, of course, tried to make it look cool. So we added some acrylic exteriors. And the outcome of the garment was this. So we've been calling it armor. But the main circuit that's inside the garment is really useful for somebody who has a stressful job. And the great thing about interesting circuitry and enabling technology is that you can put it in any exterior. So we can put this circuit into something that's pretty and shiny and blinky, which is fun. Or you could put it in a nurse's uniform, or in a construction vest, or in a factory worker outfit. And that's part of the focus on this process in enabling tech, is that core enabling technologies and processes are useful for both designers and beautiful creative work, but also for really functional outcomes. And when we're looking at this space of textile-based wearable tech, smart clothing, we see a lot of innovator prototypes in the news and take those as literal examples of what's possible. So you see an LED dress at the Met Gala, you're like, we can make LED dresses. But if the circuitry for that LED dress is repeatable, robust, reliable, secure, then you could also make heated jackets. You can also make sensing construction vests. You can make better spacesuits that keep astronauts safe through thermoregulation. You can make, Internet of Things sofas by putting sensors inside of cushions. And I think that for the future of textiles, it's really important to extrapolate up from the technology that we have now and see how that can affect a final outcome. So this chart is kind of looking at that stack of what one needs to make a garment and what one needs to make a tech thing. And when there are pieces missing from the stack, it's really hard to get to a really functional product at the end of the day. So we'll continue to keep researching in the space of smart materials and smart fibers in order to see how we can make textile circuitry more possible. But in general, there are a lot of people, especially around New York, doing fascinating work with integrating different industries together, whether that's 3D printing and parametric design for new kinds of textiles that are made out of polymer materials, or growing textiles using mycelium cultures, or an experiment like this, which I did at Autodesk a few months ago, which was synthesizing nylon with graphite so that the fiber itself is conductive and it's not a topical treatment. And so with any industry, I think it's important to think about shifting the tools and how those tools shift a foundation. And so the future of smart fabric is so much about the fiber and the enabling technologies and the tools that we have. And with that, we can really start to grow an interesting industry of smart garments, wearable tech, whatever it may be. And when we shift that foundation, it creates changes in industry that are really exciting for us, I think, as consumers. And so this is my email address. If you have any questions, thoughts, arguments, I would love to hear from you. And thank you so much for being here and taking time to see the presentation. Of course.
So thank you very much, Madison. As you pointed out, when people think about smart textiles, they still mostly think about things that we wear, whereas there are many other uses of textiles in all kinds of industries. So which do you think is going to be the earliest adopter? Like, which sector of the textile industry do you think will really go for this kind of stuff first?
Sure. The cost for producing these things is still pretty high. So I think there's actually a lot of potential in automotive and in aerospace, largely because producing those items was already very expensive. So it doesn't add quite as much of a cost as it would if it was for a garment. That's where we're seeing a lot of interest on the production side. But I think that having really interesting, light up, glowy, buzzy things in consumer apparel is something that people like to see, even if it's just a one-off. Yeah.
So actually in consumer apparel as well, do you think it's going to be mainly functional clothing like you showed there with, the exoskeletons, or is it going to be really high-end luxury fashion clothing?
Sure, I'd put it more at a bridge price point level, and I think we'll see things like induction charging pockets, heated garments, things that have really simple functionalities, but that consumers would want. And when it comes to a lot more of the show pieces, those are more of the like couture, much higher end level, because it's a really specific customer who wants to wear that. And again, that price point seems like it's more reflective.